Hello, chemistry students. Today we're going to talk about writing ionic compounds. Now, the first thing we need to do before we talk about writing it is we need to review what valence electrons are, charges, and oxidation numbers. Now, the way you find valence shell electrons is you look at the group number. The group number tells you how many valence shell electrons it is. So group 1 has 1 valence shell electron. Group 2 has 2 valence shell. We don't talk about the transition metals too much because they change their oxidation numbers, but we'll get back to that in just a minute with these three. Group 13 has 3 valence shell electrons, 14 has 4, group 15 has 5, group 16 has 6, 17 has 7, and group 18 has 8 valence shell electrons except for helium, which only has 2. Okay, now we can tell an atom's or an ion's charge by its valence shell electrons, how many it has. So our charge of our ions, once it loses or gains electrons, is the same as its oxidation number. You need to know that. Oxidation number is simply the same thing as a charge. Okay, group 1 metals all have 1 valence shell electron. Now remember, all atoms want to have a full octet with the exception of hydrogen and helium. They want 2. All of group 1 has 1 valence shell electron. It is much easier for all of group 1 metals to lose 1 electron than gain 7. So lose 1 electron, that is its oxidation number. Lose 1. Now when I say lose, I'm not going to put a negative number, I'm going to put a positive, because remember, electrons are negatively charged, and if you lose an electron, you're losing negativity. So if you're losing negativity, you're becoming more positive. So this is a +1 charge. Group 2 has 2 valence shell electrons. So the oxidation number for group 2 would be a +2 because it is losing 2 electrons. It's much easier to lose 2 than gain 6. Now let's go over to group 13. It has 3 valence shell electrons. Everything wants 8. All atoms will bond until they get 8. So we have to ask ourselves, is it easier to lose 3 or gain 5? It's easier to lose 3. There's your oxidation number. +3, because remember, losing electrons is losing negativity. You lose negativity, you become more positive. Okay, 4 valence shell electrons. Group 14, is it easier to lose 4 or gain 4? Well, it's about the same. So this group right here, it all depends on what they're bonding with. If they are bonding with a non-metal, it's going to be a positive charge. If they're bonding with a metal, it's going to be a negative charge. Group 15 has 5 valence shell electrons. Is it easier to lose 5 or gain 3? Well, it's easier to gain 3. Gain 3, that's its oxidation number. Now, if you notice here, we're switching to a negative. We're gaining 3 electrons. So we're gaining negativity because electrons are negative, gaining negativity. If we gain negativity, we become more negative. So group 15 will have an oxidation number or a charge of -3. Group 16 has 6 valence shell electrons. Is it easier to lose 6 or gain 2? It's easier to gain 2. There you go. That's its oxidation number right there. Gaining 2 electrons. We're gaining 2. We're becoming more negative. That's why it's a negative charge. Group 17. Is it easier to lose 7 or gain 1? Well, it's easier to gain 1. That's our oxidation number. This is the number of electrons that we're gaining or losing, and it happens to be gaining 1. We gain 1, we're gaining negativity, so we're becoming more negative. The noble gases have 8 valence shell electrons with the exception of helium. It has 2, but it still doesn't want any more. So the oxidation number is its charge after it gains or loses electrons. Now remember, noble gases do not want to gain any and they don't want to lose any, so its oxidation number will be 0. Now let's look at these 3 right here. I'm sorry that Google keeps coming up. Okay, silver is in group 10, and if we look at the number above that, it says 1B. And zinc and cadmium are in group 11, and if we look at the number right above that, it says 2B. Okay, these 3 transition metals do not change oxidation numbers. Silver is always a +1 charge. It's in group 1B, so you can remember it that way. Zinc and cadmium always have a +2 charge. It is in group 2b, so you can remember it that way. These three elements are the only ones that do not change in their oxidation numbers. All the others change. Okay, now that we know oxidation numbers, let's talk about the ionic compounds. Ionic compounds are always between a metal, which is a cation. Now remember that T looks like a plus sign, and a nonmetal, which is an anion, and anions are negatively charged. The goal is to make the electrons lost equal to the electrons gained. That makes the overall charge of the compound 0. Now to write the formula, you have to crisscross the ions' charges and make them subscripts. Now remember, subscripts are the numbers at the bottom. Now let's do an example. So we have sodium right here and we have chlorine right here. They are going to combine to make an ionic compound because the sodium is a metal and chlorine is a nonmetal, so I know it has to combine to make a ionic compound because ionic compounds are always between metals and nonmetals. Now sodium is in group 1 and it has 1 valence shell electron. So it's much easier for sodium to lose 1 than gain 7. And when it loses 1, it's going to have a +1 charge. Remember, this number right here is how many electrons it gains or loses. The 1 tells you how many, the plus tells you if it gains or loses. Plus tells you that it loses electrons because it becomes less negative. Now chlorine is in group 17, which means it has 7 valence shell electrons. It is much easier for chlorine to gain 1 electron than lose 7. So that's its oxidation number, gaining 1 electron, which is a -1. Because you are gaining electrons, you're gaining negativity. Now what we're going to do is we're going to crisscross. So that 1 goes down by the sodium, but we never write 1s. Now the reason why is because if it wasn't 1, then we wouldn't even have a sodium. And that 1 goes down by the chlorine. So we write Cl and we don't write 1s. We drop these charges right here. Now what this means is we have 1 sodium and 1 chlorine. If we look up here at our charges, we have a +1 because we only have 1 sodium, and we have a -1 because we only have 1 chlorine, and that equals 0. So our charges are equal to 0. So this is our formula for our ionic compound when sodium and chlorine come together and bond. Let's do another example. We have magnesium and we have chlorine. If we look on the periodic table, we'll notice that magnesium is in group 2, which means it has 2 valence shell electrons. It is much easier for magnesium to lose 2 than gain 6. So losing 2, that is its oxidation number. Now if you notice I put 2+ here instead of a +2. It doesn't matter. Sometimes you'll see it as a +2. Sometimes you'll see it as a 2+. Chlorine is in group 17. It has 7 valence shell electrons. It's much easier for chlorine to gain 1 electron than lose 7. Gaining 1 electron is its oxidation number. And when it gains, you're gaining negativity, so it's going to be a negative. Now that we've got that, we need to find out the chemical formula when magnesium and chlorine combine to make chemical. And we are going to crisscross. The chlorine, the 1, goes down by the magnesium, and we never put 1s. It's implied that there's 1 there. And that 2 goes down by the chlorine, and we drop the plus sign. So the Cl, and then we have 2 of them. Okay, so this is our chemical formula for when magnesium and chlorine combine together. Now let's check our charges. We have 1 magnesium, and a magnesium is a +2 charge. And we have 2 chlorines, and the chlorine is a -1 charge. So I'm going to do -1 and a -1, because remember I have 2 of them. So 2 -1 -1 actually does equal 0, so we're good. All right, now let's do an example. So we have calcium chloride. So we need to find out what the ions are for calcium chloride. Calcium is right here, because it says calcium. It is in group 2, which means it has 2 valence shell electrons, and it has the chemical symbol Ca. So I'm going to write Ca. Now we have to ask ourselves, 2 valence shell electrons, is it easier to lose 2 or gain 6? Well, it's much easier to lose 2. When you lose 2, that's its oxidation number. Now remember, when we lose negativity, we become more positive. Now let's look at chloride. You are going to learn here at the next video that chloride is actually chlorine. So we're going to look over here in chlorine. Chlorine is in group 17, which means it has 7 valence shell electrons. Is it much easier for chlorine to lose 7 or gain 1? Well, it is much easier for chlorine to gain 1 electron. That's its oxidation number. Gaining 1, it's a -1 charge. Now we need to crisscross. So I am going to write this, and we're going to crisscross. That 1 goes down by the calcium, and we never write 1s. This 2 goes down by the chlorine, so we have CaCl2, and that is our final formula, CaCl2. Now let's do aluminum oxide. Aluminum is found right here in group 13. Its chemical symbol is Al, so I'm going to write this over here, Al. It's in group 13. It has 3 valence shell electrons. Is it easier to lose 3 or gain 5? Well, it's easier to lose 3. That's its oxidation number. We're losing 3 electrons, so we're becoming more positive, losing negativity. Oxide, you'll learn in the next video that oxide is oxygen. Oxygen is right here. It is in group 16, which means it has 6 valence shell electrons. So is it easier to lose 6 or gain 2? Well, it's easier to gain 2, so that's its oxidation number. When we gain 2 electrons, we become more negative, so it's a negative. Okay, now we're going to crisscross. I'm going to rewrite this formula here. I apologize for the bad handwriting. Okay, this 2 is going to go down by the Al, so we've got Al, 2, and this 3 is going to go down by the oxygen, so we have O, 3, and we drop these charges. So this means that we have 2 aluminums and 3 oxygens for this compound aluminum oxide, and our final formula is Al2O3. Next example, lithium fluoride. Lithium is located right here in group 1, so it has 1 valence shell electron. Its chemical symbol is Li. Is it easier for lithium to lose 1 or gain 7? Well, it's easier to lose 1. That's its oxidation number. Now remember, losing negativity, we become more positive. Fluoride is actually fluorine. It's right here. Chemical symbol is F. And it is in group 17, which means it has 7 valence shell electrons. So is it easier for fluorine to lose 7 or gain 1? Well, it's easier to gain 1, so that's its oxidation number. Now let's do our crisscross. This 1 goes down by the Li, or the lithium, and we never write 1s. It's implied. This 1 goes down by the fluorine, and we never write 1s. It's implied. So that's our formula right there. Lithium fluoride, LiF. All right, now we're going to do magnesium phosphide. Magnesium is right here. It is in group 2 and has the chemical symbol Mg. Group 2 means it has 2 valence shell electrons. So we're going to ask ourselves, is it easier to lose 2 or gain 6? Well, it's easier to lose 2, so that's its oxidation number, +2. When it loses 2 electrons, it becomes positive. Phosphide is actually phosphorus, so let's look over here in phosphorus. It is in group 15, so it has 5 valence shell electrons, and it has the chemical symbol P. Is it easier to lose 5 or gain 3? Well, it's easier to gain 3. That's its oxidation number. Okay, now we're going to crisscross. This 3 goes down by the magnesium. And this 2 goes down by the phosphorus. So our final formula is Mg3P2.